We have introduced inductance in lecture 46. If the magnetic flux generated by the coil not only links with itself, but also links with another coil, then we say there is a mutual inductance between the two coils. Similar to the capacitance and inductance, mutual inductance may be a kind of a parasitic effect, or may be a man-made device. The distinction between them determines whether we should inhibit the mutual inductance and make use of the mutual inductance. We first review the inductance introduced in lecture 46. If the current flows through the coil, then, in according to the Ampere current circuit law, there will produce intensity of magnetic flux in a space, that is B. The magnetic flux phi will be God on the area passed by the magnetic flux density. The flux linkage psi will be formed. That is to say, if there is a current, there is a flux linkage psi. So we can define that the inductance is the ratio of psi and I. Next, we discuss the relationship between the voltage and the current of the inductor carefully. According to the Ampere current law, the current and the magnetic flux have right-hand directions. That is, the direction of the thumb of right hand refers to the direction of the magnetic flux, and the remaining 4 refers to the direction of the current. Next, by using Faraday's law of electromagnetic induction, we need to deduce how to produce electromotive force and port voltage by the change of the current. According to Faraday's law of electromagnetic induction, magnetic flux and electromotive force also should have right-hand relation. That is to say, the direction of the thumb of the right hand refers to the direction of the magnetic flux, and the remaining 4 refers to the direction of the electromotive force, that is the direction of the potential rise, that is the negative above and positive below. Under such reference direction, based on Faraday's law of electromagnetic induction, we have E equals minus d psi over dt. If L is a constant value, that is minus L times di over dt. If we want to abstract the device as a port device, we generally define associated reference directions for the voltage and the current on the port. That is to say, the voltage is positive above and negative below. In this case, according to the definition of the voltage and the electromotive force, we know that U equals negative E. That is, U equals L times di over dt. According to the derivation, we know that for an inductor coil, as long as we define the associated reference directions of the voltage and the current on the port, no matter what its internal winding direction is, we always have U equals L di over dt. Now we introduce the concept of a mutual inductance. Here is a coil whose number of turns is N1. We assume that the current I1 flows through it. According to the Ampere circuit law, there is a magnetic flux density B. It would produce magnetic flux phi11 after it passes through the section area of S. Now you can neglect the meaning of the subscript. Psi11 will be generated due to the linkage of phi11 and the coil with N1 turns. That is to say, there is a flux linkage due to the current, so we have the inductance. But here we call it self-inductance, especially. That is the relation between the flux linkage generated by coil 1 and coil 1 itself. If the path of the magnetic flux generated by coil 1, there is another coil whose number of turns is N2, then we know that the magnetic flux phi11 could be divided into 2 parts. The first part is that we call the main magnetic flux, which is generated by the current of the coil 1 and passes through the section area of coil 2. If this happens, we say that there is an inductive coupling between coil 1 and 2. In addition, there should be a part of magnetic flux not passing through coil 2. We call it the leakage magnetic flux. Now we can discuss the meaning of the double subscript. Here phi21 refers to the magnetic flux generated by coil 1 and passes through the section area of coil 2. Knowing the meaning of the subscript, we can know that the magnetic flux produced by the coil 1 and pass through itself section area is the sum of the magnetic flux generated by coil 1 and through the section area of coil 2 and the magnetic flux generated by coil 1 and not through the section area of coil 2. Now we consider the main magnetic flux. Because the linkage of the magnetic flux generated by coil 1 and passing through the section area of coil 2 and the coil number N2 turns, there will be flux linkage psi 21. So that means the flux linkage psi 21 is generated due to I1. So here's the inductance. So we define it as a mutual inductance. That is a mutual induction of the first coil and the second coil. Similarly, we can define the self-inductance of the second coil and the mutual inductance of the second coil to the first coil. I want to say something about self-inductance and mutual inductance. Firstly, units is Henry for self-inductance and mutual inductance. Secondly, self-inductance is proportional to the square of the number of turns, and mutual inductance is proportional to the product of the two numbers of turns. Thirdly, the mutual inductance between the two coils only depends on their geometric size, the number of turns, the relative positions, and the surrounding magnetic medium. And it has nothing to do with its current and voltage. Lastly, for linear inductance, we have M12 equals M21. So we sometimes don't write the subscript for the mutual inductance.